Welcome everybody to another session from Nano Research. I'm Srijit here, and in this session, I'm continuing the NEGF application using AMS band. And in this specific session, I will be showing you how we can do the setting up of the calculations using AMS band. So let me open up this band engine. So in the previous session, we have considered what are the necessary, inputs related to NEGF. And here in this session, we are just taking that carbon nanotube as an example, how we can do the setting using AMS band. The first thing, we need to select the task. From this task, it is NEGF, and then it automatically, as per the default setting, it will display the periodicity and the numerical quality. We are not changing any, basis set as well as this exchange correlation function. And then, so as per this session, this specific session, we use the non-self-consistent NEGF method in BAT. So this method represents the computationally cheap alternative to more sophisticated self-consistent methods, but it can only use through zero bias calculations. So we are going to upload our XYZ file which contains the carbon nanotube. So let me open it up. So I'm just importing those from files, and it has already been downloaded. So the carbon nanotube. So this is actually the chain, and I'm just changing to none. So this is actually that carbon nanotube, but this is not that method which we are going to display in our NEGF calculation. But I would like to show you what is actually the carbon nanotube flex. Okay. So I'm just removing it, and then going to the task. So this is actually the method. We have non-self-consistent method, self-consistent, and plus align. So we are going with the non-self-consistent method using band, and how we can generate that nanotube. So I'm just pressing the lead, and I'm going to the downloads where we have that. And now, so this is actually the carbon nanotube with the right and left leads for the electrodes. So now the lead repetitions is 3. I need to bring these two things closer. So how can we do that thing? So just changing the lead repetitions to 2. You can see that it has got a change, and then I'm just clicking on this fill and just arranging it 2 again. See, now the setting is almost done, but again we need to focus on the transmission energy gap. So why we are defining this is actually the central region which I have briefed in the first video. So we need to define our central region as per this session. This central region consists of nanotubes, same as in the lead, which can fill the central region within the lead material with this fill central region. Okay, and now you can see what is the left lead offset, right lead offset, that distance in angstrom unit. And from this panel, we can change the other parameters for this NEGF calculation. So what are the other parameters? So first, we need to perform the calculation and then to understand that what is actually exactly required. So you can see this is actually the exact calculation setup, and I have already run the calculation, and now I'm going to show you what is actually the analysis. So this is actually that calculation which I performed earlier, and I'm just going to show you what is actually the spectra, the transcription spectra, which briefs for you. 1 minute. So speaking about this spectra, this transmission function provides the insights into the energy dependent transport properties of this carbon nanotube device, which includes the presence of conductance in ballistic transport regimes. And also, let me brief you about that current voltage point. 1 minute. Just I need to take that visualization tab. So under spectra, transmission. So we can see the transmission, NEGF band transmission, and again spectra, the current. So you can see the current flow and how we can brief that current. So this is one of the applications which we can brief as a part of analysis. The current voltage curve, which calculates the characteristic reveal the electrical behavior of the carbon nanotube device under the different bias conditions, including the linear and non-linear regimes, and the presence of the phenomena like Coulomb's blockade in short CNTs. And one more thing about transmission plus density of state. Of course, NEGF can also provide the local density of state within the carbon nanotube device under non-equilibrium conditions, offering information about the distribution of electronic states and their contribution to transport. So, and it will consider the chirality and diameter for this carbon nanotube on metallic or semiconducting platforms. So, this is how SCM or this AMS band, which provides this documentation on NEGF capabilities within band, which includes specific calculations to electronic transport in carbon nanotubes. As a summary, this NEGF in AMS band offers a powerful first principle approach to simulate and understand the intricate electronic transport properties of carbon nanotubes at a nanoscale, taking into account the unique electronic structures and the influence of contacts and external biases. So right now I'm winding up the session for the day. Thank you. We will see in the next video. If you want to follow our videos, you can subscribe our YouTube channel, Nairo Research, and also you can follow our LinkedIn page. Thank you.